This is number 5 on the review, but what we're going to be looking at is finding the solution to an equation. And we're going to look at quadratic equations. And remember, a quadratic is an equation where the highest degree term is squared. So in your function, your domain is represented by some value that's going to be squared, x squared term. Cubics is when you've got cubed. Quartics is when you've got 4. So we're going to look at quadratics. Quadratics is when it's squared. So let's look at the first example. We have 23 equals x plus 4 squared minus 3. And I want to find the solutions. Now, what does that mean in a quadratic? In a quadratic equation, the solutions are what we call your roots, your zeros, or your x-intercepts. The x-intercepts is actually the best way to remember them because basically what we're looking for is where does that quadratic cross the x-axis. So for this one, there would be 2. These would be your zeros or your intercepts or your solutions. For this one, there would only be 1 because it only crosses once. For this one, there would be none. So when we solve this, we're either going to come up with 1, 2, or none as far as our roots. For 1 and 2, we'll actually get a real answer, meaning we're not going to end up with like the square root of a negative number and have to use I or imaginary numbers. We'll actually get a real solution. And you'll either get one solution only, which means the x-intercept is actually the vertex of the parabola, or you'll get 2 solutions, which means the parabola hits the x-axis twice, or you'll get something that you can't do, so a calculation you can't make, like the square root of negative 15. You can't take the square root of a negative number, which means that the intercept does not exist. So we're going to actually solve. First thing we're going to do is we're going to add that 3. So I'm going to end up with 26 equals x plus 4 squared. Okay. So my next step, I do the inverse operation of squared. I'm going to take the square root of both sides. And remember, square root, you have positive and negative, so I'm going to get the square root of 26 equals x plus 4, x plus 4, because I already took the square root. So the next thing I'm going to do is I'm going to move that 4 over. So I'm going to subtract the 4 from both sides. You cannot combine the 4 and the 26 under the radical sign. So I'm going to stick it in front. Negative 4 plus or minus the square root of 26 equals x. So for this one, you actually have 2 real solutions. Your first solution is going to be negative 4 plus the square root of 26, which is around 5. So it's going to be a little bit more than, so that's going to be about maybe a little more than positive 1 when you combine it. And your other solution is going to be negative 4 minus the square root of 26. So these are your 2 answers. Now you can leave it like this if you want to, but you have to understand that this and this are the same thing. There are 2 roots, 2 solutions, 2 zeros, 2 x-intercepts. You need to know all of that language because they are all interchangeable and they mean the same thing. Okay? So for this particular one, we can take the square root of 26. That's going to give us a real decimal number. If I were to take the square root of 26, it'd be a little more than 5. So my roots are going to be, if I wanted to actually write them out, my roots are going to be approximately 1. And then this one would be approximately negative 9. So those would be the close. If I actually did the square root of 26 and wrote it as a decimal, which is going to be 5.0 something, that's about what we're going to end up with. Negative 4 plus 5 would give you 1, and negative 4 minus 5 would give you negative 9. So let's look at the next example. Okay, so let's look at B. And this one has us solving 12 equals 2 times x minus 6 squared minus 4. So again, my first step is going to be to get the values over here by themselves, so I'm going to add the 4. You cannot combine the 4 with the 6. The 6 is on the inside. Only can cancel here. You only do it once. 12 plus 4 is 16. So 16 equals 2 times x minus 6 squared. Now we have to take an extra step in this one that we didn't have to take in the other one. You've got a 2 here. So I've got to divide both sides by 2. So that's going to give me 8 equals square root, oops, sorry. Let me rewrite that. 8 equals x minus 6 squared, which you probably saw me jumping ahead a little bit. So the next thing we're going to do is take the square root of both sides because I want to get rid of that squared. So I'm going to end up with square root of 8 on this side and x minus 6 on this side. And remember your plus or minus. Okay. So next, what I'm going to do is I'm going to move that 6 over. So plus 6 plus 6. Cannot combine the 6 and the 8 because this is under the radical. So it's going to be 6 plus or minus square root of 8 equals x. Square root of 8 is going to be almost 3, not quite 3. So you're going to have two solutions again. It's going to be 6 plus the square root of 8 equals x, and 6 minus the square root of 8 equals x. Okay? And for this, you're looking at approximately 9. X is going to be approximately 9. And for this one, x is going to be approximately 3. That's going to be close. Now, here's the thing. When you run into this, you can also write this option, and sometimes you'll be asked to do this. I can simplify radical of 8, square root of 8. If I factor the 8 and I do my factor tree, I have the square root of 8 is the same thing as the square root of 2 times 4. I can take the square root of 4 and come out, it's 2, and I can write this as 2 square root of 2. So I could also write this as 6 plus or minus 2 square root of 2 equals x. That's another option. And sometimes you're required to do that, sometimes you aren't. So sometimes you're required to actually simplify that radical. We could not simplify square root of 26, so there was no option on that. But here, especially if you get a quadratic where you have something in the denominator, if you're using the quadratic formula, you might want to simplify so it'll make your life a little easier. All right, let's do the last one. So let's look at C. And C is 18, I believe, equals x plus 1 squared. So this one is going to be, a little simpler. We can jump right into the radical. So let's take the square root of both sides. Square root of 18. So I have square root of 18 plus or minus equals x plus 1. And then following my sequence, I'm going to subtract the 1 from both sides. Can't combine those. So negative 1 plus or minus square root of 18 equals x. So again, you can write it like that, or you can separate them out. So it's negative 1 plus square root of 18 and negative 1 minus square root of 18. These are your those are your roots. Or you can write it like this. Either's correct. Now, if we want to approximate, square root of 18 is about 4.1. So x is going to be approximately negative 1 plus 4, if you round off, is going to be approximately 3. And this will be approximately, if that's a little more than 4, that'll be approximately negative 5. So those are possible answers. And remember, we talked about simplifying. Square root of 18, let's see if I can factor 18. I got 3 times 6, and that's prime, and 6 is 2 times 3. So I've got the square root of 2 times 3, which is the same as 9. The square root of 9 is 3. For every pair, remember, you can bring one out. So I can make this 3 square roots of 2 if I want to, and then my answer would be negative 1 plus or minus 3 square roots of 2. I could do it that way too. But remember, when you take the square root, it creates a plus or minus case. And then when you move that over, you've got two answers. Negative 1 plus square root of 18, and you can put that in your calculator. and negative 1 minus square root of 18. Those are your two roots. So for all three of these, the parabola is going to have two roots, or two x-intercepts.